plants, when they do the production, we as a part of the production process, we do the predictive pathogen control through using this predictive microbiology tool. But the predictive microbiology, if you look into that particular area, predictive microbiology, it's a big area. It's a very, very diversified area. A lot of things you can do using this. So I encourage all of you just to read about this thing. It's a new concept to Sri Lanka that we have pioneered through the Industrial Technology Institute, giving different kind of services based on the predictive microbiology principles. So we all know about the microbiology, microbiology, medical microbiology, soil, environment, many. But I would suggest read about this area called the predictive microbiology, and that is the future. So that comes with the computational models, especially those who are, we have any students joining with us. For them, this is, I would say, it's one of the very good area, the core content of our presentation. So here, now I'm sharing this particular slide with you to share some of the information in Sri Lanka, the Sunday Times, and there they say the everything old is new again in Kilakottu. So now this photographs, two photographs showing that a person eating kottu and person preparing kottu. So kottu is something, one of the, again, a signature food product in Sri Lanka, and I don't know how it came to our cuisines when we were during our childhood. I didn't
Excuse me,
remember
ma'am.
that we had this much, popular kottu. Yes,
Excuse me, ma'am. There's some lagging in your
yes,
video
Tanvi.
and audio. Yeah, ma'am. Hello, madam. Yeah, there's some lagging in your video and audio.
Okay, one moment, please. Yeah. Okay, so can I switch off the video because due to the weather is not that good today, so maybe the signal strength is weak. So, am I audible clearly now to you?
Yes, ma'am. Then now it's okay. It's fine. Yeah, yeah,
It's
ma'am.
okay. So, can I go without the video? Is it okay for
Yeah,
you?
it's okay, ma'am.
All right. So,
Okay, ma'am.
let me know in case if you. Yeah. Okay. Thanks. All right. So we'll move into the what where we were. So if if we have participants from India, Pakistan, or any other neighboring countries, you also have different kind of these charts and different kind of street kind of dishes. I know. So mostly, especially if we talk about India, you have these products are not mostly meaty items. They're mostly vegetarian origin. In Pakistan, you have this kind of contain meat items. Even in Sri Lanka, also the same scenario. We have vegetarian as well as non-vegetarian. I would say like in between. So this is one of the very famous street kind of. It's not street. It's in different places now, but it comes from kind of little humble beginnings from the roadside shops in the earlier days. So and but it's like this. You have this particular food tonight, so you probably have, you have more potential to get a stomach ache or stomach problem, bloating, or any kind of, I would say, loose motion kind of things. There's higher probability to get in the next morning. So those who are from Sri Lanka, the Sri Lankan crowd would understand what I'm talking about mostly. So it's because mostly these products, this particular food preparation is with, I would say, the remain chicken, fish, or mutton, beef, whatever the curries that we have, the remains that from the lunchtime, maybe from the breakfast time, is directly maybe older than that. is directly used in preparation these materials, this product. On the other hand, the rotis that are used here also may be of frozen origin and maybe not refrigerated properly, maybe a little bit quite old, prepared few days back, prepared in the morning, not freshly prepared. So here, except the vegetables that they add, most of the things are not freshly prepared, they're of old origin. So that is the reason that they say everything old is again new in killer kottu. New means match it, mix it, and add some spices and all, and make it more spicy and tasty. So it becomes new. But again, they he called it as killer kottu. So why this name killer came? Always you end up in having, kind of uh, stomach related or the gut related issue. And especially as South Asians, I would say we have we have kind of resistant towards a lot of infections, I must say. Okay, so that's one reason maybe we are withstanding, the killer stuff that we eat sometimes, but still it's high time that we use this particular, information to upgrade our food systems. It's not
Excuse me, ma'am.
that you
Excuse me, ma'am.
eat for today and
Excuse me, ma'am.
tonight and tomorrow you have to face all these, loose motion or the, diarrhea conditions. It's, I would say, observed that we this, okay. The, I can hear you. Yes, Darini, I can hear you.
Hello, ma'am. The audio is not clear, ma'am. Sometimes it's lagging.
We can't hear you, ma'am.
All right. Hope you can hear me.
Yeah. Yes, ma'am.
Yes. All
Yes,
right.
ma'am.
Okay. Extremely sorry for the weak signals. Okay, so please let me know anywhere if you feel the voice is lagging, so that I can continue, get a break and continue. So we were talking about one of the common food safety issues that we have in Sri Lanka. Now, when you have a food safety related issues in your country, where you report these things? There is a department or a particular facility called epidemiology unit. So we also have a place called epidemiology unit in the which is under the Ministry of health. So now I'm showing in your right side, in my left, yes, I'm showing you the data that the epidemiology unit received during a particular year. So if you look into different RDHS divisions, means the different divisions in Sri Lanka or the districts. So here, if you talk about the thing called the food poisoning and related issues, or the food safety related issues that comes as food poisoning here. So you will see it's the reportings are quite low. I would say quite means it's really, really low. So how this happen? It's like if you take one example as Matale, it's just 0 and 12 other consecutives that they have received some recordings. So it's because this data will, if you have come across any food safety related issue, and you will, if you go to a government hospital and then you take medications there, and then if it is like tested and your samples are tested and proved as a food poisoning or a food infection, then it will record in the epidemiology unit data. Otherwise, you take the over-the-counter medications or you meet a private channeling place doctor, there are very less probability for you to, report such incidents to the surveillance system. So due to this reason, the food safety status of Sri Lanka, both in the rural areas as well as in the urban areas, we are not able to, trace clearly. So that's one important thing. But now, that is the local scenario. But when we look into the global scenario, you take the next side of your hand, that is the timeline of US foodborne illnesses outbreaks that they have given the data. The recent data is was for the year 2024. So I got from their website. So there they say different type of bacteria or the different type of organisms that are involved in food safety threats in their country, including Salmonella, Listeria, E. coli. I would say these three are the predominant. And then there is a channel called unknowns. There are some unidentified organisms also involved. And the food, if you take the contaminated food, see that there are cheese items, there are vegetable items, there are meat items, eggs, and then there are food that comes from food chains, international food chains such as McDonald's, even McDonald's also there, see? So similarly, they say illnesses per outbreak and how many numbers were hospitalized and how many people, how many deaths were occurred due to this particular issue. So that all information they give in um, this particular document. So it's very easy to understand the prevalence of different outbreaks and what is the most sensitive food here, what is the most vulnerable organism that is causing issues in that food. So with that, I would say it's they give a very good idea about to their consumers related to their food product safety and food safety. Now, on the other hand, we just identify it as a common thing called food poisoning, maybe food intoxication. There's a huge difference between food poisoning and food intoxication. And we don't consider separately food intoxication here. So everything comes under food poisoning. And then we actually don't classify the organism wise classification, we don't give. So it's a common thing. But you're sending your products to USA or UK or European market, Japanese market, and these all developed countries, they have a similar, surveillance system like what US. So then that's why I told in my first slide, when you talk about the food safety, think not only locally, think globally. May- Irrespective of the country you are in, think about the country's system, country's status, as well as the countries that you're catering. As you're involved in export business, you have to see the end users references, end users requirements. Always you have to match with that. So that is one of the important areas that I want to highlight. So since we don't have sufficient amount of information is another reason countries like Sri Lanka and in the South Asian region, certain countries are not, you know, we are gradually upgrading our food safety, I would say. But still we have, huge loopholes where we can easily, I would say, like cover up if we get sufficient amount of data to get into a conclusion. So that is one important, lacking point I have identified here. Now, are foodborne illnesses and deaths in the US worsening? New data on recalls explains. And then now, they say despite headlines, there were fewer food recalls in 2024 than in the year 2023, but more people died from food poisoning linked to outbreaks. So then, this particular thing, now, this food recall is something very common in USA. So whenever they find any kind of, mismatch, I would say a microbiological, especially microbiological or packaging, maybe a chemical, maybe a mismatch in the finished product, the whole lot or the whole batch will be recalled. Now, what was the last time that we had kind of recalls in our system? Do you remember? If any of you can drop me a message related to this, if you remember, I would appreciate. So personally, what I feel is like it's kind of very it's not much common in countries like Sri Lanka, a thing called food recalls. On the other hand, we have been seeing in especially in the product, the milk powders, we know there were this DCD issues, the melamine issues, and there are different adulteration issues that come. And at that time, we have identified that no products were in the markets, but the product had come to Sri Lanka, it was imported, and then where it went, was it really properly, you know, uh, destroyed, terminated, or was it leaked to the market in other way? It's again a question that we really don't know about this. So that's one thing. On the other hand, we had a huge issue in aflatoxin in coconut oil, and in coconut oil aflatoxin issue also again same problem. Uh, the product people were scared and the products were not available sometimes in the market. But then we know the manufacturing was going on. As a person who kind of worked with the industry, I've seen that the industries are progressing. But how the product security or safety is assured, again, a question mark. So not all manufacturers do this, but we have that risk all the time. So the US scenario, they say the food recalls are reducing with the upgrading of the food safety system, especially the interventions by the FDA, Food and Drug Administration, which is significant, I must say. But then they have this food poisoning outbreaks and fetal food poisoning incidents are increasing. It may be because the organisms are changing, there are a lot of, it's like how this global warming impacting the food safety in the countries. In the similar way, uh, there are a lot of other different changes are happening in our food safety systems as the mutations that are happening to the microorganisms, maybe the killing step or the thermal or non-thermal killing that you are targeting may be inadequate because the organism have developed kind of immunity or I would say technically a mutation towards it so that it can withstand. So it can be. So especially if it's a very serious organism that happening, doing this kind of changes, then it is really, I would say it's really a serious issue. It's a serious food safety issue. So let's move into the Code of Federal Regulations, Part 507, Current Food Manufacturing Practices, Hazard Analysis, and Risk-Based Preventive Controls for Food for Animals. So, FSMA outlines several approaches to validating a preventive control. That's why I say now so far, how are we really going to ensure the food safety or the microbiological safety of the product? You do the manufacturing, then you get finished products from your batch, maybe for each and every batch, maybe random batches, maybe as per a particular plan. You analyze your finished product and see whether it's free from the most injurious microorganism that you're targeting to kill during your processing. Maybe salmonella, maybe E. coli 157, maybe Clostridium botulinum if it's a canned product. If it's water, maybe it's E. coli and coliform, or drink E. coli and coliform. So it's in that way. Maybe Listeria. There are a lot of other organisms. But so that is your finished product analysis. Now your batch size is maybe 25,000 cans, 50,000 cans, or more than that. But what is your sample size? It may be 2, 3, 4, 5, a random number from each batch, maybe sometimes not from each batch. Especially if you have a inbuilt microbiology laboratory in your industry, you may analyze more number of samples. But especially if you want to give a subcontract into a private or a government laboratory, it costs a lot. So therefore, you reduce the number of samples. So randomly you pick some samples, maybe some suspective samples, you just give and analyze. And they issue you a report, okay, salmonella free from salmonella 25 grams, absent. And the E. coli, it's like this absent, this is absent, that is absent, this is absent. So that is how you get the analysis report. Then what is the conclusion you're getting here? It's fine. The analysis report it looks fine. So the product is safe. But can you guarantee the whole batch is safe just by analyzing few number of samples? Can you? No. So in case if there's a breach in the food safety and the consumer received a spoiled product or a package loose product or any kind of malformed product, then it comes as a complaint, and then you take a corrective action because you identify that, okay, the random finished product analysis is no more valid. We cannot, it's not sustainable solution. So then what we will do is we will see the killing step for the microorganism that we are targeting to kill. The killing step that we, establish is properly established or not. We will validate that step. So that is how this food safety validations come into play mostly. That's why I call it comes as a corrective action. But the Food Safety Management Authority under US federal regulations, they say it should be a preventive control. Validation is a preventive control. So here, different regulatory agencies need to, enforce the, the methods, the standards, and all to do this. Although we don't have at the moment in Sri Lanka, so the products that comes to the Sri Lankan market is not probably mostly not validated. But what I get from the industry is that those who involved in exports, they are into this process, especially those who are sending products to USA and European market. So they are into process validations. So not only the regulatory agencies, here we use the different mathematical models for the validations, and we do the microbiological challenge studies and implant validations, and we use different protocols from peer-reviewed journals. So I would say this particular area is still developing. So still developing, there's huge room to more develop. And on the other hand, that's why now when any regulatory frameworks or standard is formed, then you don't need to look into the literature or journal publications anymore. But here even FSMA also saying that you read into the potential mathematical models and just check the information that is shared through the research journals, articles. It's because it's still growing. So a lot of new things annually, monthly, it's coming to the mainstream. So based on that, we are developing and we are exploring this and we are adapting it to our systems. So now, when we talk about the incident called food poisoning, so food poisoning is two types. That is, one is the infective food poisoning, the other one is toxic food poisoning. So these are the two methods from which the organisms get into the particular food item. Now, these two methods are actually again linked with the process environment. So, particularly different kind of pathogenic microorganisms can enter to your food through raw materials, through the environment, water, quality of the air, people who are involved in the production process, and the machineries, the equipments, the total infrastructure, sanitation and cleaning facilities that you have, not only for the workers' facility, also for the machines, for the equipments, for the utensils, and even the premises cleaning facility. So, this all the things are involved in food safety ensurements. So here in food poisoning, any of the source, you get the contamination. So this contaminating bacteria or fungi or virus is transferred to the food. So it becomes a potentially hazard food. I would say it's a potentially hazard food because sometimes the organism is transferred to the food and maybe the food is, the food is not supporting that particular organism to grow and multiply. Suppose anyhow, a particular organism is transferred to any particular product with very low water activity, but the organism required moderate level of water activity for growth. Then what happens? Can the organism survive there? Can the organism, multiply there? Can it release different kind of chemicals, metabolites, toxins to the environment? No. So that's why. So at that point, it's just a potentially hazard food. But then what happens if you give these intrinsic and extrinsic factors that are required for the microorganisms to grow, such as moisture, such as the nutrients, the oxygen, carbon dioxide requirement, water activity, so all and the particular temperature, mostly the optimum thing is the temperature and the time. So with that, what happens? The microorganisms are multiplied and the food is eaten by the consumer so that you start developing the food poisoning related symptoms. So infective means you have the microorganism in your product mostly. So in your fecal matter also, the microorganism is present when you get infected from that particular food. The toxic means you don't have the microorganisms, not necessary to have the microorganisms. What you have is the toxins or the metabolic products that is released by the microorganisms to your food. Now we see as an example, we have these staphylococcus. Now I give the examples in this way. So in the infection, what happens? You consume live harmful bacteria or viruses and that grow to your body and start multiplying in your body, such as salmonella, campylobacter, norovirus, E. coli comes in this way. So it takes few days for the symptoms to appear typically. But then the food intoxication is through the ingestion of toxins produced by the bacteria. So, like Staphylococcus aureus, often through this poor food handling, because Staph aureus is a commensal bacteria present in our body. So, when we don't wash our hands, when we have the cuts and wounds in our body and it's not covered properly, so this cross contamination happens. And on the other hand, I would say the other hand, the uh, Bacillus cereus, again, which is come through the reheating of food. So that's again another important phenomena that we do. Sometimes the morning food is not stored properly, and then in the night there we just microwave and eat. It's not packaged properly, it's not stored properly, the temperature control is not adequate. So what happened to this toxic food poisoning? The symptoms are, I would say, onset. It's quite fast. Within few hours, you get these issues easily. Okay, so I'll be answering to your questions. So you can drop your questions to the text box. So I see some of the participants are sharing your questions. That's great. Okay. So food poisoning, when we talk about the food poisoning, as I mentioned, it happens when you consume the food containing in preformed toxins produced by the bacteria, such as Staphylococcus aureus or Clostridium botulinum. And in foodborne illnesses, it's the whole microorganism you consume. So the microorganism also requires some time to adapt to the environment, so that in that way it will, adapt to the environment, and then it will start utilizing the nutrients present in your gut and start, releasing chemical substances. That's why it may take some time for them to, give the symptoms. So, in food poisoning is an acute illness associated with the consumptions of the contaminated food. And here we have a disease toxicant all the time in the food that are involved, and that is necessary. Should be present in a necessary volumes, necessary concentrations to make a person sick. And it's estimated that 600 million people, uh, almost 1 in 10 worldwide, fall ill annually from eating contaminated food, resulting about 420,000 deaths annually. See the depth of or the risk of the food poisoning. So, especially here, children under 5, we call young children, is again identified as a vulnerable, population as per the uh, information that is shared by the World Health Organization and UNICEF. On the other hand, elderly population, for the elderly people, the diarrhea condition is mostly fatal. So we always take measurements to stop diarrhea whenever an elderly person get diarrhea. So that's also another important thing to look after here. And when we look into the most common microorganisms, especially the bacterial ones, so you can have an idea about these organisms. So why am I giving this data and giving some kind of introductory things to you, so that you get the idea about hazard analysis, identification of your hazard. Now here, this presentation is focusing to the microbiological hazards, not the chemical or physical hazards. So sometimes even the microorganisms can cause chemical hazards such as aflatoxins or ochratoxins or any other fungal metabolites, but mostly focus on the live microorganisms that become hazards in your food chain, in your food production, in plant. So that's why Salmonella, Staphylococcus aureus, E. coli is accountable for higher number of cases annually. So when you have a risk of this particular organisms in your product, then make sure your killing step need to be validated. So how you determine your killing steps, we'll talk about in coming up slides. Next is the food that are most vulnerable. So there is a in this graph, they show like which products can get easily affected. So you can see, so although this is Center for Disease Control US document, we don't have something like this to share because we don't have sufficient information gathered. That's the reason behind that. Even I tried to get some FAO Sri Lanka information. They also I would say I couldn't get to up to the level information from there itself. And that's why I'm sharing the CDC so that we get a proper idea about the picture about the foodborne infections and illnesses in the world. So here, chicken plays a critical role, I must say, and in the pork and the fruits, so the vegetables. So it's like almost all things have some kind of probability of becoming more vulnerable. Now, the most important thing is if you look into that diagram, you can say that either of these products we usually consume daily. Dairy products you consume maybe morning and evening. Chicken is like becoming a staple now in within the Sri Lankan community. Of course, fruits we eat, vegetables we eat. So it's kind of the staple foods. Foods are becoming potentially hazards at the moment. Now, more focus into the particular organisms. We'll talk about the listeria, where we find in fresh milk and unwashed produce, E. coli in fecal contamination, Campylobacter, which comes in the undercooking and through the unhygienic kitchen cross-contamination, Salmonella, again, poor hygiene, undercooking, especially through the contaminated eggs and poultry products, Staphylococcus, when your refrigeration conditions are not good and the people, those who are involved in production is not that good. So then coral algal toxins. Now we don't have this recorded in Sri Lanka yet, the Shigella and the Clostridium botulinum. So these are all like product-based rules. So I talk about the thing called the intrinsic and extrinsic factors. So the factors that are required for the microorganisms to grow. Water activity, it's very important. Maybe your product is having moisture, no worries, but the product should not have water activity. Active water is a free water where microorganisms can come and, utilize easily. You may have jams, you may have chutneys, you may have these, pickles. What you do, you add sugar, you add salt, you add acetic, add citric, and a different kind of acids. What are you going to do is, one thing is you're dropping the pH, but here my focus is you drop the water activity. Your all water is, bounded to salts. They're bounded to sugars in the case of jams and these pickles or the dry fish. So the water activity is reduced when the microorganisms cannot grow. It's because the water activity plays crucial role in as an environmental factors for the growth of microorganisms. In addition to that, one oxygen, but not all fellows require oxygen. Some fellows doesn't require, some require little, some require no oxygen at all. So they're called anaerobic microorganisms. So those require carbon dioxide. Temperature, different organisms grow in different conditions, but I would say the body temperature is the ideal optimum temperature for most of the pathogenic microorganisms, including Salmonella, E. coli, Staphylococcus, because these all are human pathogens. So they tend to grow in the body. And especially when you live in a country which is having a tropical weather of temperature that is similar to your body, just think what is happening inside your body, same thing is happening outside the environment. So we are more and more exposed to. This may be the reason for the development of kind of resistance towards microorganisms or the infections from our end, especially those who are in the tropical environments in South Asia, the African regions and all. The resistance also may be because of this. The next is the pH, again a critical factor, and the light. Certain products, we particularly, in the packaging material itself, we say that store away from direct sunlight because the light can, support the growth. Of course, it's supporting the growth. And then the osmotic effects and the mechanical and sonic stress. So these are different kind of, factors, but mostly I would say the water activity, temperature, pH, and the nutrient content play a critical role in, growing microorganisms. So based on that one, you categorize the microorganisms based on their water activity. And by looking into the range of water activity and the organisms that can be inhibited at that particular water activity, you usually design your production. Okay, you design your production to reduce either one or more than one intrinsic and extrinsic factors to reduce the growth of microorganisms or microbial activity in your food production. So in that way, you see a different kind of products, maybe nuts, maybe businesses, maybe biscuits, maybe chips, or maybe some coffee, tea, maybe dehydrated products, maybe dairy products, meat products. So different products, you do the proper identification of the hazards as well as the conditions supporting the growth of that particular hazard. So we'll take one example here. The range of water activity in the fresh strawberry is keeping to 1 to 0.95. So this is highly perishable product, of course, and canned foods, vegetables, meat, fish, and beverages. So usually that kind of products also in the same range. So Pseudomonas, E. coli, Proteus, Shigella, Klebsiella, Bacillus, Clostridium perfringens, and some yeast are the microorganisms generally inhibited by the lower water activity in this range. See, now they have identified in this range what are the organisms that we can inhibit. Okay, so they maintain that particular range. And how are they, understanding that? They look into two aspects here. They look into that the physical nature of the product, or we would say the organoleptic qualities of the product should not be compromised when you're deciding a particular water activity range for the product. So that organoleptic quality need to be preserved well. On the other hand, identify a particular water activity range so that the most vulnerable or the risky organism that may come and contaminate that particular product will be inhibited. Clear? So you have your product, you safeguard the organoleptic property of the product while identifying the most, I would say, most injurious microorganism that can harm the product and control that particular, optimum condition for that product. So that is how you manage or you design your preservation or the killing technique here. So that is very, I would say, very critical. So that is your hazard identification and analysis point. So you identify the hazard, you analyze the hazard, and then you design your process or you optimize your process to safeguard the product by preventing the hazard getting entered or multiplying in your product. Hope this is clear to you. Second step, maybe, you look into the pH, which is another important criteria because most microorganisms grow best near neutral pH. So if you make the product either acidify or alkaline, then there is more probability for you to safeguard your product, but the product should not lose its, all sensorial properties. Since you want to, maybe reduce or increase the pH to control the hazard that you have already identified, mostly products, I would say, yeast and mold is another critical thing here that comes into, spoilage of the products with the, lower pH ranges, even higher pH, because irrespective of the pH ranges, this fellows grow. So then you need to have a proper idea about the pH range that you need to maintain so that your target microorganism is controlled or killed or dormant in the dormant stage. Sometimes you can't kill, but you can bring it into the dormant stage, which is important. So next is the temperature. So here also same thing, your whole process need to be designed to kill the organism or inactivate the organism. So here, inactivation means it's not killing. Mostly the inactivations happens when you freeze or refrigerate your product during your processing. So if the product is exposed to low temperature, then it's again whether it's very very cold or it's mild, it's frozen. So there are different areas here. The darker blue area is a frozen, and the 0 to 5 is usually called as the cold food zone. And so either of this, the bacterial growth anyway in the refrigerator, bacteria grows. So that happens continuously. But their growth is slow comparatively to the other environment conditions. But if you store the product in -18, what happens? The bacteria cannot grow. So they're inactive they're dormant, they're sleeping. While sleeping, no harm, right? So there is no harm. But then if you regenerate, you move it from this -18 zone to the temperatures, the danger zone, that is 80 to 63 temperatures, then they rapidly they start growing and they're exerting their metabolic activity, releasing different toxins and other metabolic components of the food. Then what happened? You keep on heating. So that is your killing step, I must say. So never low temperature storage never cannot be a killing step. It's an inactivation all the time. So heating is your killing step. So maybe this heating may be replaced with irradiation, or maybe filtration, or maybe cold plasma kind of non-thermal treatments. That's also possible. So here, if you talk about the temperature involvement here, when you keep on increasing the temperature, the time temperature combination for each and every microorganism have a particular time and temperature combination where they reach this thermal death, match with their thermal death kinetics. We also have it, right? So similarly, the microorganisms, although we are very macro, but I would say like our thermal kinetics are almost same. It's not much diverse when you compare with these micro fellows, but their thermal kinetics are very diversified. The Clostridium botulinum, and then its thermophilic conditions, thermophilic spores especially, you cannot destroy when you don't, reach to the sterilization conditions or UHT conditions. On the other hand, certain organisms, you may kill the same Clostridium botulinum vegetative cells in, 90s, but spores you cannot inactivate or destroy. I would say destroy at those temperatures. You have to go to 121 or more than that with the pressure. With the pressure, not only with the temperature will work out, here the pressure also required. So that is how you decide the temperature to be, utilized here. On the other hand, is the important thing, the incubation period. Now you have your production line, you have, suppose we talk about a desiccated coconut manufacturing facility where you cut your coconut into pieces and then you're sending in a conveyor and it's going to the blancher. So first step is you blanch it and then you have other steps coming. So, there is a risk of Staphylococcus aureus in the environment. Of course, a lot of people involvement here in the coconut business. And there can be a Bacillus cereus or Pseudomonas aeruginosa may come, or in any other Pseudomonas species may come, because usually the coconut is stored on the floor. So there is more chances for the soil, soil coconut cross-contamination. So through that, the organisms may get into your product. Yes. And then a lot of water is used in this kind of production facility. So if your water is not in potable conditions, the E. coli may come, or the coliform may come, or maybe Vibrio cholera in serious cases. Even Salmonella may come. Clear? So in that way, there is a risk of microorganisms to the top level now here. And then if your conveyor process is too slow, or your whole process is too slow, you stop the coconut after, once you pared open, you stop it, or keep it stagnant for a longer time, then move into another step. Stagnant there for a longer time, then moving to the other step. So what happened? You give the incubation period for those identified microorganisms. Now you know the risk here. You have identified the risk initially, and now I have to maintain this temperature, so I have to maintain this water activity, finished product, I have to maintain. So based on all things, you design your process, isn't it? So designing a food process is, we don't just look at the organoleptic things. We design it to kill and control microorganisms, because this is ultimately, although we talk about big words, this is food preservation. It may be similar to what it's just the difference is that it comes in a commercial pack. It's not kind of, mm, in retail. It will come in the retail, but not in bulk thing. It will come into pouch or pack and with an expiry date, so that it's considered as a processed food. So then if in between, if we give the incubation periods like this, it's really going to, harm your process, right? So in that way, there are different type of microorganisms may get involved in your production. So we will come into one by one very briefly. So one thing is Salmonella. Salmonella is a very diversified microorganisms. You may know about Salmonella when we talk about the poultry and this eggs poultry industry, but no. Salmonella is, I must say, it's like everywhere because it has more than 2,000 different serotypes, and this organism, when it get into the body in sufficient numbers, it has the capability of multiplying and activating, and its host range is wide, not only humans, also animals, and it's ubiquitous in your gut. So anytime salmonella may present in gut, so I have salmonella in my gut means the salmonella may present in low titers in my fecal matter. If I work in the industry, if I am not, hygienically, not much a hygienic person, and then it may come through the, uh, you know, uh, through the cross contamination, it may come into the production line. And on the other hand, the birds, it's in birds' gut as well. So birds, they do, their excreta matters or the bird poops are everywhere without any control. Especially if suppose we use a solar drying facilities, kind of facilities for to dry your raw material in outside, exposed into solar, there are a lot of chances the products or the raw material to get contaminated with the bird poops that is already contaminated with the salmonella. I'll give you one classic example, that is a talaguli that we use. It is also called a gingerly roll in Sri Lankan scenario, the gingerly roll. So that is you means from thala or the sesame. So this sesame now actually they are moving to dry the sesames in built dryers in interiors, but the traditional practice was to dry it on the rooftops, terraces, and all in the open areas for the solar drying. Then they encounter this issue a lot. So we never think that your product may have this kind of products may have a salmonella. Why? Because our traditional mindset is that when there is salmonella, it's meat and meat products, milk and milk products, egg and eggs products. But then this is the major, of course, but there are certain products. It's out of this particular region. Also, there are some products now activating, so they can remain alive in moist earth for about 1 year, and in the dry conditions for about 16 months. So it makes salmonella one of the critical organisms. Then we have to focus more on that. And then when we talk about the E. coli, it's usually present in this is widely distributed in food processing environments and with 4 different serotypes. And the most deadliest one is 015787, the organism that can survive in freezing conditions, that's in -18, and also in the pH around 4. So it grows in the refrigeration conditions, even in frozen conditions. So that is the critical thing. From where we get this? This is also coming from the gut of the humans and animals. So if you control that, the en route, you control the en route in your production line, you can control E. coli infection in your production line. So that is how you identify your hazard. Then the food involved, of course, a range of food is involved, including mostly the non-chlorinated or non-treated water, unpasteurized milk products, fruit juices, vegetables from the manure fertilizers. So he especially use the organic fertilizers, which are of course this cow dung and the other, not only cow dung, mostly we get other stuff as well in that, right? Contaminated, cross-contaminated with other, animal excreta. So then through the soil, vegetable cross-contamination may happen through that also. This contamination come in. Listeria monocytogenes, I would say again, becoming an emerging organism even in Sri Lanka. Becoming now it's creating outbreaks in Sri Lanka at the moment, and it resists freezing, it resists drying, and it can, grow at refrigeration conditions. And the product range, if you see, especially it's in ready to eat, RTF, ready to eat food. So that makes it more, serious organism, and we have to more and more focus in controlling Listeria monocytogenes in Sri Lankan scenario as well. Next is the Staphylococcus aureus. We have talked about Staph aureus earlier also. It's ubiquitous in the human body. It's ubiquitous in the environment. So you find everywhere. So how are you going to control Staphylococcus aureus? Because it's producing again these enterotoxins, and these are heat stable. So it may, ordinary cooking will not be sufficient. So you have to keep everything, all the facts and figures when you're designing a particular, food production, especially when you're designing your killing step. Now, you do any kind of processing step, doesn't matter, but each and every production process have a microbial killing step. So that is my point here. You have suppose identified different microorganisms as the risk groups, salmonella and so and so. But you have to have a proper idea about the killing step of all the microorganisms that are involved in this particular uh, production. So maybe you have salmonella, you have E. coli, you have Clostridium, and you have some other. So then see the most worst case scenario. What is the worst case scenario? Who is most resistant? Suppose the Clostridium botulinum is the most resistant, then you can ignore the other fellows. Design your killing step to kill the Clostridium botulinum. So when killing step to kill the Clostridium botulinum is effective, you can ensure that other fellows, of course, they will not survive. Clear? So in that way, you have to identify this killing step. So Clostridium botulinum, I would say, like, it's one of the most important organisms that is involved in food poisoning. It is highly dangerous. It provides onset infection on it can become onset fatal. Therefore, it's critical to control this. So most of the product that comes under the retortable conditions. So your retort is where your killing step is here. Suppose you're canning or you're bringing the product in the retortable pouches. So probably your retort is here, one of the critical instruments that you are using as your killing step. Validate your retort. That is called the thermal process validation, but even that is not sufficient most of the time. You validate your killing step. That is using a tool called the predictive microbiology tools. Similarly, you have the risk of molds as well. These aflatoxins and other ochratoxins all comes with the mycotoxin producing molds, and they usually stay in high humid environment, and you don't need to have their viable cells or their this fungus to present in live form. Fungus anytime may release toxins to your environment very. So in that way, the molds also can get into your production. The molds are, I would say, the vegetative matter of the molds. The what we call is the mycelium. Actually, you can destroy the mycelium easily with the mild heat treatments, but if they produce the spores, that is very critical again. The spores can survive in adverse conditions, even in withstanding heating, and then it may, regenerate and start producing more and more mycelia, as well as it may produce different mycotoxins, including aflatoxin, ochratoxin. Some are deadly. So that is also critical to know. So I would love to give about like 5 minutes break for you. So you can drop your messages, drop your questions that you have in the chat box. And after 5 minutes, we'll start with the second phase of our presentation. All right. So with that short break, mm, we'll move into the next part of the presentation. So here, when we talk about the fungus, as I mentioned earlier, we can't forget about aflatoxins because mycotoxins in crops is a huge issue. About 25% of the world's food crops are contaminated by the mycotoxins. So it's such as aflatoxins, ochratoxins A, and others. So basically, this Aspergillus penicillium are the organisms that are producing these toxins, which are highly heat stable, and there can be, lot of there can be a lot of disadvantages that can cause from these toxins which are heat stable, and they can survive in cooking, and they can lead to cancer, the liver, kidney damages, and their global impact also serious. Over 300 million people suffer from several, fungal diseases globally, and that's also one thing. So mycotoxin risk is one type. The other thing is the infections, the other infections that are of fungal origin. That's also another issue. Now, in Sri Lankan scenario, if we talk about the Sri Lankan case, due to the hot and humid tropical environmental condition that we have, so we have this mycotoxin issue. Even we had mycotoxin or the aflatoxin issue in rice we consume, spices we consume, coconut products, especially the coconut oil we consume, and it came into the level of, level of products such as complementary foods or the complementary feedings that we, feed to these babies or young children. So, if I tell you about the in the National Complementary Feeding Program in Sri Lanka, product called Triposha. So, in this particular product also, there was a time that we were not able to do the production due to the aflatoxin risk. So Triposha aflatoxin risk has came in a way where the corn that we used for the production was initially contaminated with aflatoxin producing fungi, and as a result, we had to stop using the corn that is produced in Sri Lanka, and then the program also had to suspend for some months, and then we, found another alternative to get the raw material or the corn from India with zero aflatoxin, contaminations. So that is how the National Complementary Feeding Program, got, restarted after this break. So you can have an idea about those who are from the Sri Lankan, from Sri Lanka, the participants from Sri Lanka. So, Triposha or that complementary feeding product is one of the, mostly it's the lifeline of many Sri Lankan, children who are especially in the rural Sri Lanka. So even that was suspended as a result of aflatoxin contamination. And then government had to take, a lot of precautions and, preventive actions to, control the complementary feeding. Other complementary products, Triposha like other products coming into market, and they have to regulate those products as well. So that is the level of, risk that we encounter due to the fungal contamination in food. Then we talk about end product testing. Why this end product testing fail? I have explained you that the batch testing is no more a valid tool to have a better idea about the product safety, because it ignores the processing environment totally. It ignores the human handling. And of course, it ignores the ingredients that can change between batches, because sometimes we know that even within the batch the ingredient compositions are, there are certain changes can happen. And on the other hand, is the statistical limitations, associated with in-product testing. The sample that the testing is totally, rely on the assumption that the contamination is evenly distributed or throughout distributed in the batch. But just see the Salmonella or E. coli, when it's present in very low levels, do you accept it to have an heterogeneous, scattered way so that you can, uh, uh, easily you may miss it? If it's homogeneously and evenly distributed, of course you will have in uh, each and every can or pouch, you may have the contamination. But when the organism is in very low levels, it is heterogeneously scattered. Do you expect it to be present in each and every product? No, it's not. So it's again, when you do a random sampling, there's higher probability you miss that particular one. And I must tell you, you may argue that sometimes how if it's present in higher levels. Of course, if it's present in higher levels, you don't need to do the analysis, because the product itself will provide you different symptoms. The coconut oil or the coconut milk, when the coconut milk is or the coconut water in bulk UHT packaging, when it's contaminated in an export consignment, it will burst out when the titer is high. If it's a canned product, when the product is inside the can, if the Clostridium contamination happens and the tire is high, it will burst out. The can shape will be out. Mostly you will see the bloating or bulging or bursting. These things happen when the gas forming bacteria is present out. Clear? So then even physically by seeing, you can say there's an issue with the product. From sensing, you can say there's an issue with the product. From the sensory analysis, you can say there's an issue with the product. But when there is no such issues, when the issue is random, of course, statistics also, it will limit, because as I told, unless and until you have a proper laboratory with a very good capacity, just a small laboratory with one or two analysts cannot do this. We have very good capacity. In the commercial run, you can do the analysis. Otherwise, you have to give it to the private or any other third-party laboratory, which is again, you have to spend on that. So because of all these issues, we usually, tend to analyze a hand-picked number of samples, which is again not sufficient, That is why we suggest you to do this thermal process verification thing, which will validate your killing step. Now you know what is your killing step. You know what is the hazardous microorganism present in different products. So it's not always theoretical. It's not written. You have this product and this is your hazardous microorganisms. No, work out on it. You have this product and the ingredients that you use in your product and the thermal processing you expose your product into. Based on that, the hazardous microorganisms that may survive or multiply in your products varies. So it varies from you and it varies from the similar product in other manufacturing. So I have experienced coconut milk UHT processing facilities. Each and every facility have their own time temperature combinations. Their own time temperature combinations. Why? Because based on the environment, based on their protocol, based on the ingredients they use, of course, their risk, they calculate it. So it is not some norm. It's not in public domain. You just read it, get it and do it. No. So there is some kind of workout for you to understand the most injurious microorganisms and the other hazards. And then you design your killing step to kill that most injurious microorganisms so that your other organisms also will be killed, other hazardous ones also will be killed. And not only that is sufficient, you validate that killing step. Once you validate it, that what is it? It ensured that your process is going well and no problem. So that is safe. You're in safe hands. Okay. So for that purpose, we use what basically we do is you have your production going on. Okay. Suppose your most injurious microorganism is Salmonella. Then, first step, we do thermocouples to different parts of your production line. It's in very simple language I'm talking here now. And we will see whether the temperature is penetrated sufficiently and the time taken for the penetration and the cooking is sufficient as per your plan. That is one thing. Second thing is the predictive intervention. So in the predictive intervention, what happens? You don't just put the thermocouple. What you do is you're targeting to kill the salmonella. So you're inoculating salmonella alive, not salmonella. Can you inoculate salmonella to the alive? No, no, because that is very harmful bacteria. So you have a similar kind of salmonella-like organism, which is belongs to class 1 category, which is non-pathogenic. So this non-pathogenic Salmonella-like organism is inoculated in known concentration, and that is called as the surrogate microorganism. So the surrogate microorganism is inoculated with your product, and then you expose your killing step. So the raw material or the intermediate product is exposed to your killing step. So that killing step may be blanching, it may be UHT, it may be some retort, it may be pasteurization, it may be filtration, whatever. So just let it go through that killing step. It's mostly thermal killing step. I prefer. I prefer means I do. We have from the clients, and once it goes through that, then get your product and analyze that product. So you have to have a proper idea of the initial microbial load of your product, as well as the initial amount of microorganisms you inoculated per gram you inoculated, or the surrogate organism you inoculated your product. You have to have an idea about that, and the microbial or the survived microbials in your end product. So when you have the initial and end, simple initial and end microbial counts, so you mathematically you can calculate and get that which kind of log reduction is happening through your killing step. Most of the killing steps are fixed to have a 4 to 5 log reduction, 4 to 5 log reduction of microorganisms. This is the worst case scenario for the most injurious microorganisms, the time temperature combination target for the most injurious microorganisms. And in the worst case scenario, it's like if you get your line infected with 10 to the power 8 or 10 to the power 6 colony forming units per gram of salmonella. See, usually that is not practically happening, but that may be the worst thing that can happen. So that's why we call it the worst case scenario. So you prepare the worst case scenario, and if you can if your killing step can have a 5 log reduction, it means 10 to the power 8 to maybe in your end products you have a 10 to the power 3 or 10 to the power 2. That kind of survival rate if you have in your end product, then ultimately when we do the calculation, we get up to around 5 log reduction CFU per gram. So that is what we target in killing step. So that is how we validate the killing step. So once you validate the killing step, then you can run your CIP, or if you can write hash CIP to remove the traces of the inoculant present in the environment. But this is of course a class 1 microorganism. So therefore the risk towards risk is comparatively, I would say, it's like least, and we make sure that it remains least. So the predictive microbiology offers significant advantages by using the mathematical models to forecast microbial behavior in food, replacing slow, expensive traditional testing with rapid and data-driven decisions. And it helps for food safety through precise risk assessment, improve shelf life estimation, and optimization of your processes. So it's never your product is or your process is undercooked or overcooked when you use these predictive tools. So it's accurately cooked. So all risky particles are removed and it's accurately cooked so that your energy is controlled. I mean, energy is saved. Your cost of production is saved. But product quality is improved and the product safety is improved and the most injurious microorganisms were taken care of and always prepared for the worst case scenario. So for that, you do the killing step validation. So what is your killing step? Mostly it can be a cooking step. It may be a freezing, blast freezing, such as it can be a pasteurization or a UHT, or it can be sometimes chemical treatment. So as I mentioned, maybe a salt addition, maybe an acid addition, it may be a sugary stuff addition. So whatever the killing step, but it should not be the inactivation step. Now I talk about the inactivation and killing both separately. So please don't misunderstand the inactivation and killing. So inactivation is you just let them sleep for some time. They're inactive. Doesn't mean they're dead. Yeah, inactive, not dead. But killing means you kill. So the treatment that you plan here to validate is always your killing step to the predictive tool, not your inactivation step. So please identify these two as two significant areas that you have to focus on. So what are the advantages you get through this validation, killing step validation? It helps achieve maximum food safety and protect the consumers because always preparing for the worst case scenario. You have 5 microorganisms threat, we target for the baddest one, the most resistant one. The best time temperature combination to control the most resistant one. Not only that, the worst case scenario, that is the 5 log reduction. See, Salmonella, E. coli 157 come in 5 logs. It's a huge number. Usually, before you get into this, you may have physical symptoms of the product, as I mentioned earlier. So in case, even if you miss that, still you're safeguard through this. So that's why we call it you're meeting the worst case scenario. And it helps meet the safety standards like 5 log reduction of that particular that is set by the regulatory agencies like FDA. And it helps determine effective treatment. Sometimes you may change your time temperature combinations. Then you do a revalidation of your killing step. Maybe you want to take it down. Maybe you want to take the temperature up. Maybe you want to, adjust your holding time. Never adjust those without, validating any change if you are doing. If you're increasing, it's not maybe a problem because anyway your organoleptic quality will be affected if you increase your cooking time and cooking temperature. But if you're decreasing, of course you have to validate it so that your all injurious stuff is calculated within that portfolio, which is critical. It saves food industry millions of dollars by avoiding recalls and other legal penalties due to the foodborne illnesses outbreaks. So I talked about the recalls and the threats earlier. And it helps to retain consumer confidence. And of course, it supports this business success. So what are the requirements for the killing step? So here you need to have a detailed design, an experienced microbiologist, a statistician, and a containment facility. Also, we call it biosafety level 2 facility or level 3 facility. If you are doing a viral validation, suppose for norovirus or any kind of virus, if you are validating, you need to have a BSL biosafety level 3 facility laboratory. And it is recommended that you conduct your analysis, or if you get this facility from any service provider, so it should be conducted in triplicates. And of course, the 3 tests need to be run in 3 different days because today is a rainy day, the environmental atmospheric condition, when it's not controlled, then it's a sunny day would be a different and another tropical day would be a different. So 3 days we do in triplicates. And then any potential variations between the production runs will be identified. And in the killing step validation, the other thing is the team will troubleshoot if there is any temperature penetration related issues are there. So even that is troubleshooted before validating the killing step. And then the enumeration of the treated samples as well as non-treated samples are important. So samples that are, exposed initial counts after inoculating of the class 1 organism, the final count, which is also called as the treated samples that are exposed to heat treatment, as well as the sample without any inoculum. No class 1 organism or nobody is there, but just the sample that was aseptically drawn from your line before your production start or the running starts. So these are the different steps that is involving in plant validation. And you have to do a lot of things, a lot of work prior to going for an implant validation. As I mentioned, you identify your hazard. Also, whether you have a single or a multiple products to be validated, and based on that one, you identify your hazards and you categorize the product. Product categorization will reduce the cost and it is more efficient. So 2 products per category that represent the worst case scenario, you can run at once. So that is important. And always go for the worst case scenario. I think I have given you sufficient examples for you to determine the worst case scenario in your processing facility, the water activity, the pathogenic resistance, the cooking temperature, the zone temperature, the coldest spot, the shortest time. So, in case suppose you have, you did the finished product analysis like in the traditional way you are doing, what is the probability to get a colder spot of your batch as an sample? The coldest spot means when store the samples, give the heat treatment, there will be 2, 3 cans randomly may have the coldest spots getting, one can will get this coldest spot. So the coldest spot will not have the sufficient heat treatment and the holding time. So that may be one of the risky or the vulnerable ones. So what is the probability if you do a traditional sampling protocol and do a traditional endpoint, finished product analysis, you pick that coldest spot and do that. So that usually doesn't happen, right? So that is why we say do the killing step validation. So this is actually a third party validation. So you have to go for a third party validation here, and you have to ensure the sampling size and the number of samples that you take for the process is statistically significant. Talk to them for that one and get the adequate control samples, because even this can be misleading sometimes, like the in product analysis. And then surrogate inoculation is another critical thing, that how to do this surrogate inoculation. That is also very important, how you're going to inoculate. Sometimes if it's a filler head, how you inoculate it. If it's a packaging material, how you inoculate it. If it's a UHT, how you inoculate. If it's a blanch of coconut pieces, how you inoculate. If it's a baby food, how you inoculate. If it's a dryer, how you inoculate. See, the thermal processing is very, very diversified. So how you inoculate it? It's a spring, or it's just aerosol spray, or just inoculate into can and close the can. Is in that way? Which way? The mode of inoculation and the surrogate. Salmonella, there are surrogates for salmonella, but that doesn't matter for other organisms. So E. coli 157, there's one separate surrogate. If you have a Clostridium botulinum vegetative cell, you have one surrogate. If you have a Clostridium botulinum spores, you have Bacillus stereothermophil spores. So in that way, this is very, very diversified. You can read, you can get a lot of information available in the Google and the other domains. So you can get that information as well. And the culture you use is always an ATCC culture, American type culture, collection culture. Never use this here and there isolated identified culture where the culture's whole genome sequencing and the safety assessment is not done and the culture is not classified under BSL 1, biosafety level 1. So these are basic things that you have to know and talk to your microbiologist before you get into this kind of implant validation thing. So let's move into the process validation lifestyle. So the stage one is the process design. So here it defines the manufacturing process using the data gathered during development and scale-up studies. And in the stage two is designing the validation protocol, and executing is typically requiring minimum of 3 consecutive full-scale production batches. So the 3 days in 3 batches, the surrogate is inoculated and the initial and final samples were taken off and analyzed in the laboratory, and then do the statistical analysis and predictive calculations using the predictive tools to give the amount of log reduction achieved. Stage three is continuous process verification, the systems and the data tracking in place to ensure that your process remains constant throughout for each and every commercial production routinely you do, which is again critical because that is your ultimate goal. And you need to have a VMP. What is VMP? Is the validation master plan. So this is the fundamental roadmap for validation activity. So you have to have a proper idea about the exact premise, the equipment that you're going to validate, and the utilities surrounding by it, and the process that you're going to validate. And you have to have proper responsibilities of this validating process. So the validation, we need to have a when we take the support of a third party laboratory, that third party laboratory, they have to have authorization to do the validation. The process authority should be there. The process authority should personally visit your plant and see how the killing steps are going on at present and what are the changes need to be done. And then, because now validation of killing step will not tell you what to improve. It will tell you whether you have to improve or not, but it won't tell you to which extent and how to improve, because that part is not addressed here. So that's why what we usually do, any troubleshooting if required in killing step, we do the troubleshooting initially. We do the repairs, we do the troubleshooting, we do the calibration, we do the uncertainty adjustments, and then the compact thing will be validated. That is your final thing you validate. Right? So it's not you validate today, change tomorrow, do another. No, because this is time consuming, this is money consuming, and this is very expensive protocol. So therefore, you have to have this 4Qs, design qualification. So you providing that, and on the other hand, the supplier, the service provider will fix into this 4Qs. When you disclose your design to them, so they see that this designs means the intended requirements and GMP guidelines or not. And then the installations, verifying equipments, piping, and other softwares are installed to manufacturer specifications or not. Then demonstrate that the equipments operate correctly across all intended operating ranges or not. And then providing consistent, reproducible performance under normal operating conditions or not. So when these 4Qs meet properly, then it's kind of practically the validation is your process is eligible to do a killing step validation. And then cleaning as well as analytical validation, there are two different types. So cleaning validation is the minimizing cross-contamination and demonstrating that the cleaning protocols are working effectively. Suppose you use different kind of cleaning protocols for cleaning your equipments, cleaning your bench, working bench, cleaning your utensils, cleaning on your floors. So this may be a food processing, this may be a pharmaceutical processing. So cleaning validation is possible to do with the class 2 challenge microorganisms. If anybody wants to know more about the challenge microorganisms, I would talk about this after this presentation, since we are almost like meeting to our fixed time now. So, and the analytical methods are the documentation, documenting that the test methods are accurate, precise, and reliable for verifying product quality. So you have to have, establish analytical methods need to be used during the validation. Usually the analytical validation people know about it. So it's your responsibility, since you're exposing to your factory to the third party service provider. You also should have what are their qualifications and how are they involving in this. So surrogate selection is another important thing. As I mentioned, a lot of scientific literature is important. Hope you remember about the scientific literature I have discussed earlier in my first slides. So that is important. And the thermal death time of the surrogate appropriateness is very important. So salmonella killing, thermal death kinetics is similar to the salmonella surrogate. Similarly, for E. coli, it's different. For Clostridium, it's different. So D and Z values are again critical to identify. And of course, identifying the process parameters and the target log reduction is another critically important thing that we have to focus here. Time and temperature to achieve the target log reduction, and applying the data to conduct the in-plant validation of different products. So selection of the surrogate is, it's again, this is since selection of a surrogate is a risk mitigation strategy designed to test process efficiency, such as the killing steps, so equipment, sanitation, whatever. So, ideal surrogate is mimicking the activity, but not the pathogenesis, the other activities of the target organism. The physical resistance and other things remain same. So without any hazard, we can use that. So we here consider about the safety, and then equivalent or greater resistance comparative to its master, and the genetic stability. It should not transfer or mutations or gene transferability should not be there, because otherwise it will be a serious issue. And it should be easily cultivable as well as easily detectable in specific agar media, such as the tryptic soy agar and the specific ATCC culture media that is suggested by the American type culture collection. Now see, if you have the sterilization process in your hand, you can have an idea about the common microorganisms that you need to use. These all are class 1 microorganisms. If you use the saturated steam, you have Clostridium sporogenes and Geobacillus stereothermophils. Clostridium sporogenes, it's for the vegetative cell validation. Geobacillus stereothermophils, it's for the spore validation. So in that way, filtration, you have another one. For peroxyacetic acid, if you're using, it's another one. So irrespective of the mode of validation, mode of killing step, whether it's a heating, whether it's filtration, whether it's acidification, there are different options are there. So for fungal spores also, there is a possibility, especially the Aspergillus fumigatus, which is also again opportunistic pathogen, and the Aspergillus flavus, aflatoxin producing organism. For these two organisms, the Aspergillus brasiliensis, also called as A. niger, is widely used as a standard highly resistant test organism for industrial biovalidation. So for the thermal validation and sanitation and packaging validations and airflow and environmental monitoring, for all these three instances, this particular organism or the Aspergillus brasiliensis, you can be used. So thermal validation means if a product has a baking, pasteurization, heating, cooking step. So we can paste a spore strip in your particular oven or that particular area, and then we can see the spore destruction, how it's happening when you apply your heat. Similarly, sanitation, packaging validation, like you use different kind of food contact surfaces or packaging materials, and then we could inoculate this particular strips spore suspension into your packaging material surface, and then you may run your CIP or your UV or your irradiation or chemical sanitizer treatments to see the log reduction. Airflow and environmental monitoring means, as I mentioned, the fungus, usually you won't have the mycelium or the vegetative cells, but you may have spores in your production line that will, affect your product quality. So therefore, the most of the fungus, of course, these are airborne in nature, so that you can validate your filtration system, your AC system, your environment by placing these particular strips in particular areas and see how your disinfectant or the sanitization protocol is sufficient or not. And then I talk about the decimal reduction time. So the D value is very critical in predictive microbiology. So this decimal reduction time is the time taken to reduce the microbial population by 90% at a given temperature. It's like that you use with 1 lakh spores initially, and one D value will reduce them to 10,000. Hope it's clear to you. So this D value is usually expressed in minutes. So it will come with the temperature, this particular temperature, and the D is this much. So it will come in minutes, and it defines the heat resistance of a specific microorganism. So if you have a higher D value, means the microbe is more resistant. So you have to give more and more time for heat and sterilization. Hope it's clear to you. Then the Z value or the Z value, it's called as the thermal resistance constant. This is also another D and Z. It is basic things when you do the surrogate-based validations. So how many degrees you must raise the temperature to make the sterilization process 10 times faster. So that is your Z value. So that is usually expressed in Celsius, centigrades, or Fahrenheit. So it describes how sensitive an organism's heat resistance is to temperature changes. A low Z value means what? It's that microorganisms' resistance drops very quickly with small increase in temperature. So if the microorganisms' resistance is dropping, when you increase the temperature, means it's a good sign, right? So Z value is calculated in temperature. So this Z value and D value are the two important values that you used in predictive microbiology related analysis. So these values help professionals validate and optimize sterilization cycles, and they ensure that all harmful microbes are destroyed while keeping processing times as short as possible to prevent thermal damage to the product. So that's why I told you that D and Z value will support the F naught value under area under the curve representing the total lethality of 121.1 Celsius if you see this graph. So these two values are important for you to dramatically change the organoleptic properties of your product while assuring the maximum safety of the product. So this is the framework of your validation process. So you match the validation thing, whether you are doing a thermal, drying, chemical, or whatever it is, identify proper surrogate organism and proper specific metrics, and then do the inoculation. Identify how to do the inoculation, in which strength you do the inoculation, and then do the in-plant testing and see the log reduction, and you document it. And if it's really reaching to the 5 log reduction, means that indicates that your killing step is safeguard, it's validated, it's good. So the final log reduction to be the minimum achieved log reduction, not the average. So always you consider it as the minimum. You get the average, you get maximum log reduction, you get minimum log reduction when you do the mathematical calculation, but you always see the minimum. Sometimes you may have 6 log average, okay? But you have minimum you got is for your sample was 3 log reduction, maybe your cold point. Yeah, yes. So that may be your most coldest point or the sample that is present in your most coldest area of your retort is again contributed or accompanied to this particular analysis. So that you usually missed in your finished product analysis. Just finished product analysis. So that's why I'm telling this again and again that thermal process verification using surrogated microorganisms and validating your killing step is one of the critical things that will safeguard your product, your consumer, your time, your money, as well as your energy. So the application of this method, process, test, and the other evaluations, in addition to monitoring to determine whether control measures or the combinations of controls has been operating intended to establish the validity of the food safety plan. So you can read more on 21 CFR 507.3 in the federal regulations to have a better idea. So with this, I would come into the final remarks of my presentation. So you can contact me through vasu@ithia.lk, and this photograph showing the endpoint validations using surrogates that we did in different industries like and different segments like filler heads, dryers, packaging materials, UHT, steam blanchers, ovens, and also I would say it's like very diverse, the environment, and you always need a process authority to do this. And so here the Mrs. Samantha Madage, Samantha Taitarotelke is acting as a process authority here. So I would say that he's the process expert here, involving in understanding the process. And my part is as the microbiologist here, the predictive microbiologist, the designing of the predictive microbiology validation part. So it's a combination. So you have to have all these parties with you to get best out of and validate your uh, product. I would say process. Yes. So with that, I would thank the CSERT for inviting me for this presentation, and I hope you have got basic idea about this predictive microbiology, which is one of the emerging areas and introductory areas in Sri Lanka. This is only very few public presentations have been made on this particular area up to now. So you can contact me in case if you have any doubts. I'm just texting my WhatsApp number. So if you have doubts, you can, or if you need to get the service from ITI also, you can contact us. And yes, I would be able to share the presentation slides with you. It's mentioned, Mohammed Sajid is asking for the presentation slides. I think I can give the presentation slides to Dharini, so Dharini can share from you. Yes. And then another question I'm seeing, the coliform is infective or toxic? Yeah, coliform is actually it's an infective one. So there are metabolites that are released from the coliform, but when you have the live coliforms, then it makes your water non-potable. Okay, so whenever we do a water sanitization protocol in the municipal water, we do coliform to mitigate the coliform, to control the coliform. We always use this, what we call this uh, chlorination and other methods so that the coliform is disrupted. But it can be easily disrupted. You usually don't validate coliform related processes because that is easy. The vegetative cell, it's destroying, not like other spore forming and heat stable microorganisms. Yeah, so that's all I see in the yes, in the textbooks. Yes. If you have any doubts, I'm here to answer you. Thanks.
Thank you, ma'am. I want to express my sincere gratitude to Dr. Vasundhara Divisekara for her insightful and comprehensive explanation on hazard analysis to predictive pathogen control. Her profound knowledge and expertise provided valuable insights for the participants across diverse industries. Again, thank you, ma'am, for invaluable contribution and commitment. Ladies and gentlemen, now we are transitioning into the highly anticipated Q&A session. So I will present the summarized questions that you have been submitted in the Zoom chat box. After that, the floor is open for the audience and have the opportunity to engage directly by turning on your microphones, and you can pose your questions to the resource person. Now is your time. If anyone has questions or wants to clarify anything with the trainer, feel free to ask by turning on your microphones. The floor is yours.
I think Dharani, they may need to read some more so that they get questions, because this is kind of introductory thing that they got now today. Is it?
So if you have any questions, you can ask now. Ma'am, there's a question.
Yeah, this question related to yes, food poisoning. Yeah, you may get food poisoning through water. Of course, if your water is contaminated for a prolonged time, and if the water is with salmonella, vibrio cholera, which usually produce different toxins, then there is a huge possibility. So that's why sometimes in certain instances, the contaminated water makes people ill very rapidly. It's because the water is contaminated and these chemical, toxins are released to environment already. So it's present in the water. So when you consume, of course, you can have the poisoning. Yes.
So I hope all your questions and clarifications have been satisfactorily addressed. So a big thank you to all participants who have actively engaged by asking insightful questions. So your curiosity and contributions are truly appreciated. Thank you again for making this session more meaningful.
Thank you, everybody. Have a good day. Bye bye.
Ma'am, we have to wait, ma'am, a small time. So we have to take a small photograph. So
Oh, is that so? Yeah. I'm
as we draw close to the end of this free online webinar on smart food safety, I would like to express my sincere gratitude to Dr. Vasundhara Divisekara and all the respectable attendees for your active participation and valuable contribution, making this webinar a vibrant pool of knowledge exchange. To commemorate the participation, we are pleased to announce that e-certificates of the participation will be awarded to each participant via your email. To acknowledge your participation, we are delighted to announce that certificates will be awarded exclusive to those participants who provide their valuable feedback by filling out the feedback form. The link to the form is conveniently provided in the chat box. Now you can find it. Kindly take a moment to share your thoughts and insight by filling out your feedback form now. We appreciate your time and contribution to our ongoing commitment to excellence. Now the time is yours. You can fill out the feedback form. Good. We trust you gain valuable insights from today's session. So please take a moment to complete our feedback form and please remind only those who submit feedback form will be eligible for the e-certificate. So please everyone kindly give your feedbacks by filling the feedback form and thank you for being a part of our learning journey. Now we move into another special moment. Today we are creating a virtual memory book. So let's capture this moment. Please turn on your cameras. We want to snap screenshots of all the wonderful participants. I believe your smiling faces will make this experience even more memorable. So now we request you to please turn on your cameras and join with us to make this session more memorable. One, two, three. Again, one, two, three. Thank you all. your enthusiastic support and helping us to capture these screenshots. That is truly appreciated. Your smiling faces are the heart of our virtual memory book. Thank you for making this moment extra special. Before to say goodbye to you all, I would like to take a moment to remind everyone to stay connected with us on our social media platforms. You can follow, like, and comment on our posts in Facebook, Instagram, TikTok, YouTube, as well as LinkedIn. We regularly share a diverse range of posts, including technical insights, audit updates, and subject related content. These posts not only provide valuable information on food safety management systems, but also cover a wide array of other standards. By staying connected, you will have the opportunity to expand your knowledge beyond FSMS and stay informed about the latest industry trends. Have a nice day and safe journey. Thank you. Thank you all.